Hello everyone, Sebastian here. First problem I decided to tackle is the problem of scale. Maps in Lords of War will be quite big, certainly bigger than a single screen, which means there are two things to consider. First, obviously, is how to display just a fragment of the game world at the time, and with that done, how to let players navigate this limited viewpoint around the whole game world. Second thing, and less obviously, is what to do with all the game world that player currently can't see. Rendering is very expensive in terms of computation complexity, so I really shouldn't be rendering things that are outside of the screen borders. Thankfully, both of those issues can be solved with a bit of relatively simple math. So let's get started. The idea of a camera or a viewport into the gamer's world isn't very difficult to imagine, considering that it's taken straight from the real world. Most natural example would be of our own eyes. You can't see the whole world at once now, can you? In relation to a game, one could imagine a traditional board game with a bigger and bigger board. At some point it just becomes too much and you need to separate it into chunks that fit on your kitchen table. Of course, that just means that you have a bunch of boards that you swap as you need. Not a bad idea actually, just ask Nightlore fans. While perfectly viable option and would fit very well with the idea of the scenes I talked last time, it's not exactly a seamless continuous world. For that, the viewport can't just jump from one room to the next, but instead it must smoothly pan across the huge stretches of the world. That said, imagining some sort of contraption that would roll and unroll a game board in all directions as needed is way outside of my abstract thinking skills. Thankfully, for computer games it's way easier. Putting the idea of a camera away for a moment, try to imagine a game as a scene. It has some sort of terrain, units, cities, all those things. But this isn't what a computer sees. A computer sees a collection of entities, each with its own position, all drawn on some sort of background. If we just pick some arbitrary coordinates and check which of those entities are close enough, we'll get just a fragment of the entities collection, a fragment of the game world, a fragment that the camera sees and displays to the player. And if we move our camera coordinates a bit, we can just check again and we will get a new piece of the world to show. And that's how panning camera works. Simple as that. Implementation of this is very simple too. Just check all entities from the current scene, get assigned transform component, check what is the distance from the camera position, and if it's under the calling distance, translate it into coordinates relative to the viewpoint and draw it on the screen. At this point you might be wondering about few things. First, what is Chebyshev distance? Most people, when asked about the distance between 2 points in Euclidean plane with Cartesian coordinate system, would say, well, they would likely say you should leave them alone. But some people would reply with this. This is commonly known way of calculating distance by applying Pythagorean theorem. It has a huge problem though, it's really slow to compute. Specifically because it needs of calculating a square root. You might not think it's a problem now, but when you need to calculate it for 1000 entities 60 times per second, it will become a problem. Chebyshev distance, on the other hand, is an approximation. It doesn't produce same results as Euclidean distance. It's basically wrong, but it's also equally wrong at all times. Calculating it's also really fast in comparison, and it produces really nice grid-oriented results. It's also referred to as chessboard distance if you believe Wikipedia. And this grid-oriented result fits really well into how Lords of War will present its world. Second confusing thing might be this coordinates translation thing. Entities in the game world can be very far away from the actual center, but when the camera is over them, I still want to have them in the middle of the screen. By subtracting camera's position from the entity's position, I'm translating the world or absolute position of an entity into relative local coordinates of the camera, which I can use to position actual drawings on the viewport. And finally, panning itself. Really simple, just changing the position of the camera when the mouse coordinates are close to the edges of the window. And that's panning camera with culling done. Now I'm getting a bit tired of those white squares, so I think I'll make proper sprite component next. See you in the next video.